This is Debo Engineering Consultant. We are discussing today, we are discussing the 1838, COP 1838 for the epilogue. Let's look at the advantage of the COP 1838. Some of the advantages are that it is efficient, very efficient, very efficient in the drilling. Then the other good part about 1838 is that it has a good piston shape. Let's look at the weakness. The weakness that we have actually seen is that limited in frequency, meaning the speed at which it can drill can be slightly slower than other drifters. Let's compare it to 3038. 3038, it has high frequency. Let's look at another area is that complicity. Complicated valve design, complexity in design of the valve or valve design. Let's look at parts of the drifter. The parts of the drifter are, this is actually the this is actually water. This is a flanted of this is a flanted. This is a flanted. This part is a flanted. This is a shank. This is a shank. This part is a shank. Okay, the water has to come here, then it goes out here during the reading. So whenever we are looking at 1838, what we look at is actually the flank part, which is the flanted. The inside part here, this is a flash head. Let's move on. This part is a lubrication. This part is air plus lube oil. This this part, orange part, is for lubrication. Let's look at the whole entire. You can see the lubrication is actually lubricating number of parts. Here is the whole drifter. Okay, so let's look at the gearbox. The gearbox actually is lubricated by grease. So meaning that during maintenance, this gearbox supposed to be greased nearly every shift. This is actually the smaller gear. This part is a smaller gear, and this guy is a main gear here. This is the main gear. Inside here, there is a shank. There is a driver. Inside, there is a driver there. It's actually what drives the shank. Is it what transmits the rotation? The movement is generated by a rotation motor. You can see there are two hoses there. There is a red and a blue hoses there. So meaning that one is a supply and one is a return line. Then this is what generates the rotation. Then the rotation is transmitted to this smaller gear. This smaller gear transmitted to this bigger gear. In the bigger gear, that's where the driver is. So whenever we are troubleshooting the rotation system, this is how it must flow. I think we are done with the rotation part. Then we come to the damping area. The damping area, we can't forget this small piece here. It's a sleeve. That's where this is a damping piston here. This is a damping piston. It's actually actuated by this green part. This green part is a 40 bar or pressure from the pump. Then there is a regulator there in order to produce about that, in order to regulate it to about 40 bar. Its essence of the damping piston is to push the shank in front in order to increase the lock drill steel contact. There must be a contact between the drill steel and the lock in order to increase the efficiency during drilling. So this part here, this is a damping piston. This is a damping piston. So you can see there is an accumulator. We have real damping accumulator here. There is also a check valve. The essence of this check valve is to ensure that whenever there is overpressure, this check valve must open in order to maintain the damping pressure system, which is about, there must be about maybe, must be 40 bar. Then during the reading, it might lie maybe to 60, 70 there. But it must maintain at least 50 bar in a normal drilling if everything is okay. The water pressure is okay. There is no the lock contact is okay. So this is what is actually there in the damping piston. This accumulator must be charged to about 25 to 35 bar. This accumulator, damping accumulator. So I think we are done with the damping. Let's come to the main percussion. The main percussion is actually this part. This is a block for percussion. You can see there is actually this guy here. This guy, it's the guy that I'm shading, and there is also this guy here. The guy that I've actually shaded. I've shaded 2 areas. That is a guide for the piston. Those are piston guide. They are very important in order to ensure that the piston is well guided during the percussion. And the percussion is actually activated by the pressure, which is 200 bar or 180 to 230 bar. That's a range. Okay, let's put it there. It's about 180 to 230 bar. 230 bar pressure. There is also the accumulator there. You can see there is an accumulator there, which is charged to about 100 bar. 100 bar. And you see the oil flow here is the oil goes to the valve. This valve is the main percussion valve, which controls the percussion. Okay, let's come to the piston. You know that this oil pressure is coming to the piston, and there's a movement in between the piston. The piston must go in front to hit the shank. Shank later transmitted to the drill rod in order to hit the lock, whereas there is rotation there is what generates the drilling. Okay, so this is where we are. You can see that there is some leakage. That leakage is necessary for lubrication of the piston itself. Okay, there is a bolt here. You can see that it's sending oil to the oil coming from the piston itself, plus the oil coming from the valve, the piston valve. There is also some leakage there. So that oil must come to the piston for lubrication, for more lubrication, right? Then it returns to this guy here, the back head.